Okay, here's our last video for section 5.3. We're going to do example number 5 and then go to example number 7 because we kind of skipped around a little bit. Talking about the fundamental theorem of calculus, part 1 and part 2. If I ask you to take the derivative of this antiderivative, we should be able to use our part 2 of our fundamental theorem of calculus. But if you remember from the other examples, when we found the derivative of the antiderivative, that only worked when we were going from a number up to a variable. And this doesn't say that. This says we're going from a variable to another variable. And so what we have to do is we have to actually make it look like the fundamental theorem of calculus. And so instead of going from negative x to positive x, can I use my rules or properties of integrals to separate it into two different integrals? Can I go from negative x to 0 and then again from 0 to positive x and then add them together, which would be the same thing as going from negative x to x all in one? And why would I do that? Well, I would do that because now I have a number to a variable. Well, in this one, I have a variable to a number, so I've got to switch that around. I have to make sure that I go from 0 up to negative x. But you remember the other rule for integrals? That when we flip the limits, we have to negate it. And so making sure that I use those properties correctly, if I'm going from a number up to a variable and I switch it, then I have to make sure that I add that negative in the front. All right, so now I have an integral that says we're going from a number up to a variable. If this is the antiderivative and I want to take the derivative, well, we know that the derivative of the antiderivative, using my fundamental theorem of calculus, says that I could plug this in to my variable, and then I just have to make sure that I multiply by the derivative of that upper limit. So that's what I have. I've plugged in my negative x into my variable. I've multiplied by the derivative of that upper limit, which is a -1, but then don't forget I have another -1 from the beginning. Again, I plugged in my upper limit, I multiplied by the derivative of that upper limit, but don't forget we have a negative in the front from flipping those limits of integration. Okay? I'm going to do the same thing for the other piece. If I'm taking the derivative of this antiderivative, then I should be able to use that fundamental theorem of calculus that says they're inverse functions of each other. I should be able to take this upper limit, plug it in, multiply by the derivative of that upper limit, which is just 1, and so I end up getting a 1 times x cubed. So in this second piece, I have a negative x cubed. That's a negative x times a negative x times a negative x. That's a negative x times another negative. That's a positive. Times another negative. That's a negative, right? So don't you end up with a negative x cubed plus an x cubed, which ends up to just be 0. All that work for just a 0. But that's how we do it. If there is a derivative of an antiderivative, we have to make sure that it goes from a number to a variable. So we might have to separate it a little bit in order to make sure that we can use that fundamental theorem of calculus. Okay? All right.